Hi guys, welcome to my channel. In this video, I'm going to talk about SJF or Shortest Job First Scheduling Algorithm. By looking at the name, you can see that it is shortest job first. Means jobs or processes which have shorter or smaller execution time or CPU burst time will be given the CPU first. This works with the assumption that for all the available processes, their execution time is known in advance. When we know their execution time, we know which jobs are shorter, which jobs are longer. That's when we can pick up shorter jobs for execution first, then we can pick up the longer jobs. That's how SJF works. For example, there are three processes A, B and C. Let's say the execution time for A is 4 and for B 2, then for C 3. Now we know their execution time, we know job B or process B is the shortest among these three. That's why B will be picked for execution first. After that C will be executed, after that A will be executed. So, one more thing to remember here is that this is a non-preemptive algorithm, meaning for process C to begin execution, B has to complete. For process A to begin execution, C has to complete. There is no other way C can get ahead of B. There is no other way A can get ahead of C. Until a process that is in execution completes, no other job can come and execute. That is a non-preemptive algorithm. Now, let's see what is the advantage of this SJF. The advantage is that this has got the minimum average waiting time among all the scheduling algorithm. That is minimum average waiting time. Minimum average waiting time. In that way, this is the best algorithm. But this has got some disadvantages as well. The first one is that when shorter jobs keep coming in, the longer jobs will be waiting for a long time because they don't get the CPU time. Only shorter jobs will keep getting the CPU time. They will have to wait for long time. That is one of the disadvantages. Another one is that the implementation of this SJF. The implementation is difficult. This works, like I told you, with the assumption that the execution time for the processes is known in advance. But in reality, knowing how much time a process is going to take for its execution in advance, it is not possible. It is not practically possible. What we can do is we can estimate the execution time based on various factors. But knowing the exact execution time beforehand, that is not possible. That's why the implementation gets difficult for SJF. Now, let's take up an example and see how to calculate average turnaround time and average waiting time for SJF. Here I have 5 processes A, B, C, D, E and their arrival time is given in milliseconds and their burst time or execution time is given in milliseconds. Now, let's calculate the average turnaround time and average waiting time. First we'll calculate the turnaround time for each of these processes. The turnaround time is completion time minus arrival time. And the waiting time we know is turnaround time minus burst time. First, before we calculate the turnaround time, we need to know the completion time because turnaround time is completion time minus arrival time. For that, let's draw a Gantt chart. This is 0 here. Now let's look at the processes here. We have A, B, C, D, E. At arrival time 0, we have one process, that is A, and it executes for 3. That's why A will be taken up for execution first. it executes for 3 milliseconds. At time 0, there are no other processes available, only A is available. That's why we take up A first. Okay, it executes for 3 milliseconds, and at 3 millisecond, we see that there are 3 processes which have come in, B, C and E. Because it has come at arrival time of 1, it has come at arrival time of 2, and this has come at 3. So, this executes for 3 milliseconds. At 3 millisecond, we have 3 more processes which have come in. Among these 3, B, C, E, let's see their execution time. We have 4, 2 and 2. So, C and E, they have shorter CPU time. But there is a time between C and E. So, we'll break the time using first come, first serve. Here, C has come at time 2, E has come at time 3. That's why we'll take up C for execution first. C will execute for 2 milliseconds. That means it will complete at 5. Now, E will be executed. E will execute for 2 milliseconds. It becomes 7 here. Now we have one more process, that is D, which is coming. Among B and D, we know that B is shorter, so B will take up first. It will execute for 4 milliseconds, so it becomes 11 here. Then I have in the end D, which executes for 5 milliseconds, that is 16. So this is a Gantt chart. By looking at this, we know the completion time. Now let's calculate the turnaround time for each of these processes. For A, it's going to be, for A the completion time is 3 and the arrival time is 0, so it is 3. This is the turnaround time I'm calculating. For C, process C, C completes at 5 and it has arrived at time 2. So it's 3. Now I have process E. It is completed at 7. 7 minus the arrival time for E is 3. So it is 4. Then I have process B. Process B completes at 11. 11 minus B has come at 1. So it's going to be 10. And finally D. For D it is completion time is 16 and it has arrived at 4. It is 12. Now we know the turnaround time for each of these processes. Let's calculate the average turnaround time. Average turnaround time is going to be, we'll add all these up, 3 plus 4 plus 10 plus 12 by 5 means 3 plus 6, 10, 20, 32 by 5 means 6 by 6 are 30. So the average turnaround time in this case is 6.4 milliseconds. Now let's calculate the wait time for each of these processes. Then we'll calculate the average wait time. Here we know that wait time is nothing but turnaround time minus burst time. Let's calculate for each of the processes. For process, this is waiting time. For process A, the turnaround time is 3 and the burst time is 3. 3 minus 3, 0. Then we have process C. Process C, the turnaround time is 3 minus the burst time is 2. That's why it's 1. Then I have process E. It is 4 turnaround time and the execution time for E is 2. That's why it is 2. Then I have process B. B, turnaround time of 10 and for B the execution time is 4. That's why it is 6. In the case of D, turnaround time is 12 and the execution time is 5. That's why it becomes 7. Now we know the waiting time for each of these processes. Let's add them up and divide by 5 to get the average wait time. So average wait time is equal to 0 plus 1 plus 2 plus 6 plus 7 by 5. This adds up to 16 by 5. 5 3s are 3.2. 3.2 milliseconds is the average wait time for this SJF. Now we know the average wait time in SJF. Now what will I do is, for the same processes, let me calculate the average wait time using Fcfs, and then let's compare the average waiting time. Here the average waiting time is 3.2. Let me note down here so that I can erase the rest of the board. Average wait time is 3.2 milliseconds. Now let me erase this part of the board. Now let's draw a Gantt chart using Fcfs for the same set of processes. 0. If you see here the processes, see that A has come at 0. So first come first serve, it is A will be taken up first. It executes for 3. Then comes B at 1. So it will be executed. B for 4 milliseconds, that means it is 7. Then C will be taken up. C that executes for 2, that means it is 9. Then I have process E. Process E will execute for 2, that's 11. Then I have process D in the end that executes for 5, that means completes at 16. Now we know the Gantt chart for Fcfs for the same process. Now let's calculate the turnaround time for each of these processes. For A, it is completion time is 3 and the arrival time is 0, so it is 3. For B, it is completion time is 7 and the arrival time is 1, so it is 6. For process C, the completion time is 9 and the arrival time is 2, so it is 7. For process E, the completion time is 11 and the arrival time is 3, so it is 8. Then for process D, the completion time is 16 and the arrival time for D is 4, that is 12. Now we know the turnaround time here. Let's calculate the wait time for each of these processes. For A, the turnaround time is 3 and the burst time is 3, 0. For B, 6 minus the burst time for B is 4, so it is 2. For C, the burst time is 7 and the turnaround time is 7 and the burst time is 2 and it is 5. For E, it is 8 turnaround time and the execution time is 2, that's why it is 6. Then I have process D, 12 turnaround time and the burst time is 5, so it is 7. Now that we know the wait time for each of these processes, let's add them up and calculate the average wait time. So average wait time is going to be 0 plus 2 plus 5 plus 6 plus 7 by 5, which is nothing but 7, 13, 20. 20 by 5, which is 4 milliseconds. So in the case of Fcfs, the average wait time is 4. But earlier when we calculated using SJF, the average wait time was 3.2 milliseconds. That's why the average time in SJF is lesser when compared to Fcfs. Thank you.